Friends, as given in the homework, we can solve any questions. So today we are going to solve a questions in which we are given two random variables x and y that have a joint PDF of that is given fxy x of y a 1 plus xy, and the range of x is mod x less than 1 and mod y less than 1, and it is the value of the joint PDF is 0 for all the other ranges. Now we are required to find value of a marginal PDF of x and y, and we are required to find whether x and y are independent or dependent. So we will first start by calculating the value of a. For calculating the value of a, we will use the property of probability density function, that is the area under the curve is the area under the curve is 1. So that is minus infinite to infinite, minus infinite to infinite, the joint PDF of x of y of xy dx dy equal to 1. So putting the value from here and also putting the range of x and y, and here the range of x is from -1 to 1 and range of y is from also from -1 to 1. Putting the range of x and y here and the value of fxy, that is joint PDF, in this equation 1, we get -1 to 1 a 1 plus xy dx dy equal to 1. Now we will first solve for dx with respect to dx, and taking the common term as is a constant, so we can take the constant outside the integration. So we will get a integration -1 to 1, another integration -1 to 1 plus xy dx dy equal to 1. So we will now integrate with respect to dx. On integrating with respect to dx, we get x plus x square y by 2, value from -1 to 1, integration with respect to dy, that is equal to 1. Putting the value and on putting the value and solving, we get 1 plus y by 2 of -1, and it is again minus 1 square by 2 dy equal to 1, -1 to 1 a. Cancelling out these terms, we will get 2 dy equal to 1. Now we will integrate with respect to dy. On integrating, we get -1 to 1 equal to 1. So putting the value and on solving, we get 4a equal to 1. That's why a equal to 1 by 4. So we get the value of the constant a as 1 by 4. Now putting it in the original equation, we get the joint PDF is now fxy of xy, that is equal to 1 by 4 into 1 plus xy for mod x less than 1 and mod y less than 1, and it is 0 elsewhere. Now we will go for the second part. That is marginal PDF of x and y. So we the marginal PDF of x is given as integration of the joint PDF of x and y with respect to y. So now putting the range of y, now putting the joint PDF here and integrating it with respect to dy, we will get the marginal PDF of x. So that would be minus 1 to 1, 1 by 4, 1 plus xy dy. So taking the constant out, we would have 1 by 4 minus 1 to 1, 1 plus xy dy. Now on integrating with respect to y, we will get y plus x y square by 2 minus 1 to 1. So on putting the values, we will get cancelling out the opposite terms, we would, and on solving we will get 1 by 4 into 2, that is equal to half. So the marginal PDF of x is half in the range minus 1 to 1, and it is 0 elsewhere. Now similarly, we will calculate the marginal PDF of y. So it is given by f y of y, that equal to integration of the joint PDF of x and y with respect to dx. Putting the values in the range of x, we will get 1 upon 4 into 1 plus xy respect to dx. That is equal to, taking the common out, 1 by 4 integration minus 1 to 1, 1 plus xy dx. On integrating and putting the, on integrating, we would get x plus x square y by 2 value from minus 1 to 1. Now on putting the values, we would get square by 2, cancelling out the opposite terms, and on solving we will get 1 by 1 upon 4 into 1 plus 1, that is 2. So 1 upon 4 into 2, you would get the value as half. So the marginal PDF of y is half in the range of y less than equal to minus 1, greater than equal to minus 1 and less than equal to 1, and it is 0 otherwise. And after solving the first two parts, we will solve for the independent. Whether we will see that whether they are dependent or independent. So we know that the marginal PDF of f of x is half, and the marginal PDF of y of y is also equal to half. We are solving for parts that is to prove x and y are dependent or independent. So now on multiplying both these terms, we get half into half, so that's equal to 1 upon 4. But the joint PDF of xy is 1 upon 4, 1 plus xy. So we can see that these two terms are not equal. That is, fx of x into fy of y is not equal to fxy of y. So we can say that as they are not equal, so x and y are not independent, because we know that for functions, for the events to be independent, for the event to be independent, the probability of AB should be equal to probability of A into probability of B. But this property is violated here, hence they are not independent. Thank you.